Okay, this is Math 9, class number 1. I thought we'd start with some jokes. I found these on a site called fatherly.com. And of course, we all know that dad jokes are the absolute best, so here we go. Why was the fraction apprehensive about marrying the decimal? Because he would have to convert. Yeah, don't think too hard about that one. Why do plants hate math? It gives them square roots. Why is the obtuse triangle always so frustrated? Because it is never right. Why was the equal sign humble? Because she knew she wasn't greater than or less than anyone else. What do you call a number that can't stay in one place? A Roman numeral. Why should you never talk to Pi? Because he'll go on and on and on. Why are parallel lines so tragic if they have so much in common? It's a shame they'll never meet. How do you stay warm in any room? You just huddle in the corner where it's always 90 degrees. Why does nobody talk to circles? There is no point. Did you hear about the mathematician who was afraid of negative numbers? They'd stop at nothing to avoid them. After a sheepdog gets all the sheep in the pen, he reports back to the farmer. All 40 accounted for. But I only have 36 sheep, says the farmer. I know, says the sheepdog, but I rounded them up. And the last one? There are 3 kinds of people in the world. Those who can count and those who can't. Wait a minute, I have to do this one. If you catch this one, you're pretty good. What do you call a man who spent all summer at the beach? A tangent. All right. Now to begin with the more serious business of today. Flip to page 314 and 315 of your textbook. And we will proceed. Unit called, as you can see on page 314, Similarity and Transformations. Now, a very important concept in similarity and transformations, which we've done before. Today's lesson will consist of review of previous concepts. Symmetry. Where is a line of symmetry? A line of symmetry is exactly where you can cut something into exactly 2 equal parts. So if we look at this flag here, I have no idea whose flag it is. Ich kan het do. Een lijn doormogen. Oder do. Down here, across here. If I look at our humble Canadian flag over here, it only has one. Do a line door. There it's equal. Here I can't because the maple leaf isn't equally split. Can't exactly go here either. So the Canadian flag only has one line of symmetry. The flag of British Columbia, I would say, only has one line of symmetry straight down the middle. I would say these are the flags of, I believe this is Saskatchewan, and that's Nunavut, you can't cut them equally anywhere. They have no lines of symmetry because do, but don't change the color. Entonces the star goofs things up. The flag of Japan has umpteen lines of symmetry, and it probably has at least 4, if not more. Su and Su and Shrig, and you can probably do some other ones if you tried really hard, but we'll leave that for now. So, lines of symmetry, an important concept. Let's flip over to page 314. Here we see an example of a triangle. And I made a beautiful sketch of said triangle. This triangle color get copied to page 316. I'm sure you get how incredible that is. Now, there's some concepts that you need to remember by way of review. You got to know what an isosceles triangle is. Two sides are the same. One is different. And if you have a triangle with two sides that are the same, it's also going to follow that two angles are the same as well. That's the number one concept, is knowing what an isosceles triangle is. The second concept, remember the Greek guy, Pythagoras. A squared plus b squared equals c squared. Remember that? And then if we have any triangle, whether it's a right triangle, an isosceles, an equilateral, doesn't matter, a scalene, doesn't matter, angles equal 180. It's half of a rectangle and also half of a circle. Rectangles and circles are 360 degrees. Angles of a triangle are 180. So we're going to use all this information to solve Mr. Triangle up here. So beautifully sketched. This triangle, these two symbols here indicate that this side is equal to this side. These two sides are equal. This one has no symbol, so it's of a different length. And I forgot one part of the sketch down here. So this whole thing is an isosceles because this side is a different length. These two are the same, so this is an isosceles. If we split it exactly in half, we get two right triangles. So what we have is an isosceles triangle equally split to create two right triangles. So, if this side is 37, this angle is 37, and this is an isosceles triangle, then this angle must also be 37. And if this is isosceles, which it is, with the two indicators here, then this side must also be 5. Okay? Now, let's begin by solving for the angle on top. Do. Very simple idea. You take the idea that the angles of any triangle add up to 180 and do host 180, and you know the other two angles are 37 and 37. 180 minus 37 minus 37. I'm feeling lazy. I'm recording this on a Saturday morning. I get 106 degrees from my calculator. 106. And if I want to do the two individual angles down here, conic simply 106 divided by 2. I'll do that in my head. That's 53. Half of 100 is 50, half of 6 is 3, gives me 53 degrees. So that solves all the unknown angles. We've got some unknown sides here. Now this triangle is divided exactly in the middle. So we can use Pythagoras to find the missing side of one right triangle, and then it will be the same for the other side. So we are going to use a squared plus b squared equals c squared. C is always the long side. Okay, so 5 is C. A is the short side, that's 3. Although these two sides can be interchanged. This could be B, this could be A. Doesn't really make a difference. But this side is always C, the long side. So but for our purpose here, we'll say this is A, this is B, this is C. So A squared, 3 squared, plus B squared equals 5 squared. So what does it mean to square a number? It means to multiply it by itself. 3 times 3 is 9. B squared is what we're trying to find, equals 5 squared. 5 times 5 is 25. So now we have a question that says 9 add an unknown number equals 25, an unknown squared number to be precise. 9 add an unknown squared number equals 25. How can we find out what that number is? 25 subtract 9, and 25 subtract 9 would be 16. Obviously our unknown side is not 16, but this number was squared. So we have to find its square root. Square root of 16. This just happens to be a perfect square. 1 times 1 is 1, 2 times 2 is 2, 3 times 3 is 9, 4 times 4 would be 16. So our two unknown sides would be 4. And we go back up here, 4 and 4, and the total then is 8. So the right triangle has a side of 4. The isosceles, if we put them together, has a side of 8. And by the way, if you go over here, got a 90-degree angle here. If we add all these up, 90 at 37 at 53, you will, of course, get 180. 90 at 37 at 53, 180. Just like you get 180 when you do 106 at 37 at 37. All right? A triangle is a triangle is a triangle. It doesn't matter. The 180 degrees always applies. It doesn't matter if you're working with right, isosceles, scalene, equilateral. Doesn't matter. Doesn't matter. Scalene, by the way, does not beseiten iola undished. Isosceles is this one here. Two sides the same, one different. Equilateral, they're all the same. Right triangle is subidos. Usually all the sides are different, in fact always, but one of the sides is a square, is a right angle on aphrodisitina, and they're all different. Scalene is simply all the sides are different and there is no right angle. Like scalene var suvosvi dos. Equilateral, simply ola gleich. Isosceles and right, you see up there. Okay? If there are questions about that, you can't ask them. You're not here. So, let's have a look over at page 317. We have 3 triangles here. We're asked to find, for this one, ACB. ACB is dabbeide unten icket. ACB. The middle, when they're labeled with letters like 3 letters like this, the middle letter is always the 1. Okay? ACB is the one you're trying to find. Okay? So they're asking us to find the one down in the corner for this one. So let's work out these three exercises. Page 317, number 1a. Well, out der 28 und a 76. Now there's two ways of doing this, of course. You get your sides that add up to 180. 180 minus 28 minus 76. Sorry, you couldn't see that, but now you can. 180 minus 28 minus 76. I'm not doing that one in my head by any means. That comes out to 76. Now, if I'd taken a closer look at this triangle, I would have recognized it as an isosceles with two equal sides, which would have immediately told me that angle ABC or angle ACB would be the same as angle ABC, right? So if you look here again, this is the same as this. So there's two ways to find the 76. You can subtract, you can say, hey, it's an isosceles. ACB is 76 because ABC is 76. So two ways of doing it. Now we want to find, for this next one, GEF. GEF, das ist der Boy da unten in die Ecke. Und GFE, GFE is on top. So here and here. Now, let's turn this baby like this. And now we can see these two sides are equal. Got the little indicators here. It's an isosceles. So that means that this angle and this angle are equal because this is the top. If you have these two sides that are equal with the indicators here, then you know that it has to be these two angles that are equal. Not this one and this one, but this one that match up mit de zwei Seiten was gleich sind. Okay? So, follows then that the angle here is 36 degrees. So, B, angle GEF equals 36 degrees. Now, how am I going to find angle GFE, the guy on top, the F? Well, I'm going to take my two 36s and add them up. And I got a 72. So now I know my two bottom angles are 72. And I know that the total is 180. 180 degrees minus 72 degrees. $108. That's B. Now let's have a look at C. This one, like flippen, pseudos is pseudos. My book doesn't want to allow me to do that. So now, so we're stuck with this. Got, again, an isosceles. This side is equal to this side. And the angle that's different from the other two is 36. So the two angles that are the same are our unknowns in this case. HJK, 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 that's this one. KHJ, KHJ is this one. So we're trying to find the two angles down on the bottom here. It's an isosceles, they are the same. And we know this one, 36. So here's the procedure. Take your total of 180. Subtract the angle that you know. 180, take away 30 is 150, minus 6 is 144. Now, this is the total of the two angles. The total of HJK and KHJ is 144, and they are equal. So we'll simply do 144 divided by 2. What is half of 144? Half of 140 is 70, half of 4 is 2, it's 72. So angle HJK equals 72 degrees, and therefore it follows that angle KHJ 72 degrees. Any questions about that? We've reviewed Pythagoras again, isosceles triangles, and the idea of 180 degrees. Let's have a look at the worksheet that you're going to be doing for homework. I'm going to do a few questions from this worksheet. We won't start with Pythagoras. We're going to start with isosceles and equilateral and on the whole 180 degree idea. We're going to do this first question together. Okay, number 1. And then from questions 3 to 11, you can pick 6. As it says, 9, 10, and 11 are extra challenge. If you want to do these, great. Give them a shot. They're not that hard, but they are more of a challenge than the other 6. But to get you going on this worksheet, we are going to do the first one up top here. So, BCA. BCA. I'll find this angle here. How did I do that? I have no information. I have no numbers. I do have information. There's assembly here, assembly here, assembly here. When each line of a triangle has this symbol, that indicates that's an equilateral triangle. The sides are all the same length, therefore the angles have to be the same. So what are 3 numbers that add up to 180, given that a triangle is 180 degrees? Which number can be multiplied by 3 to make 180? That number would be 60. 60 times 3 is 180. 60 at 60 is 120. Add another 60 is 180. When you've got an equilateral triangle, the 3 angles are all 60 degrees each. DCE. DCE. This guy down here. Take a good look. I got the 2 symbols here and no symbols on the bottom. These also mean equal. This is the same as this. Okay? So, we have equal sides here and unequal side on the bottom. We know we're dealing with an isosceles triangle, and we know that one of the sides, the side that's different from the other 2 is 50. So I can go simply 180, take away 50. It's going to give me 130. And then half of 130, you guessed it, half of 100 is 50, half of 30 is 15. 50 add 15 is 65. DCE, 65. Let's label these as we go. 60, 65. DEF. 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 The outside here. Well, I know I've got a 65 in here because it's an isosceles. These 2 are the same. So, another concept you have to remember that I didn't mention right from the start, but it's simple enough. A straight line always has which measurement? And the line Ganskrodis, 180. Just like a triangle. Straight line always has a measure of 180. So what you have here is a straight line, and you've got an angle coming down onto this straight line and splitting it in half. So the question just becomes, what is the remainder of the line? And I can simply find the remainder of the line by doing 180 minus 65. Is 115. B, C, D. An interesting one. B, C, D. Was isn't the angle do? Still. Okay. Hold on, I have to do something here quickly before we continue with our lesson. Okay, I'm back. Hope you have enjoyed your breather. Here we have still a straight line, but two angles hitting it. We have a 60-degree angle and a 65-degree angle. So we want to know what the remainder of it is. Okay? So what do? 180 minus 60 minus 65. We have 55 degrees. Det är kråda line. Det kommer ett sva angles över. So the remaining angle is 55. BCD. BAG. BAG. That angle though of the outside. Those are equilateral, so the vastado is 60. So what do we do here? This is 100, Kroda line is 180 with this angle coming down on it, right? So 180 minus 60 is 120. BAG. A bit of a different measurement from this one, of course, because this is the equilateral with all angles 60 degrees. This is an isosceles with a 50 and 265. So, of course, this angle is 115. This one is going to be 120. Bislandish, because the triangles are different. But very simple to figure out, because you know this guy here is a 60. And it's the straight line concept. 180 minus 60 is 120 degrees. Finally, G-A-H. G-A-H. This guy over here. Miamdo is 60 and 120. We can complete the full circle here to solve this. Not the nicest circle you've ever seen, but a circle nevertheless. I'm wondering if this has clicked for anybody. Då sa det två änglar som i både 20 och 160. It's I said då kolla evil flipped. So this guy here is 120. We're looking for that do. And he would be, yes, 60. Der und der sind gleich. We're dealing with a circle here. Der und der sind gleich. If you need more proof, of course, and this again, straight line with the angle intersecting it. So, and you know that this is a 60, so 180 minus 60, about 120. And then, if you want to really prove that this one is 60, 360, take away 120, take away 120, take away 60, like so. 360, take away 120, take away 120, take away 60. A60. Okay, that's this example. 3 to 8 down here, I would say, are easier. Niet zo streng hoeft. 3 to 8 down here are probably easier than what we just did up there. Just apply the concepts. Isosceles, and the whole idea of 180 degrees, whether it's a triangle, whether it's a straight line, and of course a circle being 360. I don't think that's going to come up with any of these 8, but it could come up if you choose to do some of the more challenging ones down here. All right, let's do a few Pythagoras exercises then. So your homework is to do 6 of these. You can do all 9 if you like. It's fine. And you also have some of these for homework. Not sure if there's enough room on the sheet. Well, there probably is to do all of them. Let's start. We'll do number 1 and 2. Then I'm going to leave you with 3 and 4. And I'll also do a couple down here. But we're going to go up here first. So here we have a triangle with a 17 and a 19 and an unknown side. We have our hypotenuse. We have our long side. A squared plus 17 squared equals 19 squared. A squared, 17 times 17 is 289. 19 times 19 is 361. What do I do next? This becomes, sorry, that's the plus sign, so I need an equal sign. This then becomes a number at 289 equals 361. Got to subtract 72. And of course, our final step is to find a square root. It's not a perfect square, so I need my calculator. 8.48 or 8.5. And I can label it here as well. Now, let's go over here. A squared plus b squared equals c squared. In this case was ich die lange Seite nicht. Okay? 5 squared at 13 squared equals c squared. Because it's this lange Seite, the unknown. 5 squared is 25, 13 squared is 169. I add those two up. 25 add 169 is 194. Square root of 194. 13.9, almost 14. 13.9. Okay, a couple more examples. Leave you with 3 and 4 to do on your own. 5 and 6. This time we simply don't have drawings. So here we have a side A and a side B. We do not have a side C. So we're dealing with the long side. 12 squared add 5 squared equals C squared. 144 add 25. 169. Square root 169. 13. Here we have a side A, we do not have a side B, we have a side C. So in this case we know the hypotenuse, we know the long side. A squared plus B squared equals 10 squared. 64 add B squared equals 100. So a number, 64 add a number equals 100. How do I find that? By subtracting. 100 minus 64 equals 36. Square root of 36 is 6. So these were both perfect squares, which sometimes you'll get, sometimes you won't. So, to wrap up our lesson, on this page, do 3 and 4, and then 7, 8, and 9. And on the other page, do any 6. You can do all 9, it's up to you, but do at least the first 6. Most of this is review. A few tiny little new concepts mixed in here and there. Nothing that should give you any great degree of difficulty. With that, we will wrap up. We are going to end this conference now.